Good day, everyone. Welcome to the Food Safety Forum. I'm Audrey, your host for today. Before we start, here are a few things to note. Anytime you have a question, type into your chat box at the bottom of your Zoom window. Direct your question to the speaker so that we can get the right person to respond. We may not have time to answer all questions, but we will get back to you individually via email after the webinar. Now, what comes to mind when you hear the word food safety? In the last 2 decades, there have been cases that rocked the food industry worldwide. In 1993, there was an outbreak of E. coli linked to undercooked hamburgers at Jack in the Box restaurants in the United States. It killed 4 children and infected more than 700 people across 4 states. And up to the early 2000s, the mad cow disease caused widespread panic because we can get sick by consuming the meat of infected cows. Infected individuals could suffer from depression and a loss of coordination, followed by the onset of dementia symptoms. There's also the melamine scandal surrounding milk powder from China, which happened in 2008. The tainted milk powder contained a substance that was used by some companies to boost protein levels in their products. This poisoned thousands of children in China, of which 6 of them died. So food safety is critically important because it has serious implications on our health. So what are the best practices to address these concerns? Today, we have 3 experts that will share their insights. Our first speaker is Robert Rogers from Mettler-Toledo. Robert will talk about preventing contamination and upholding safety in food production. Let's hear it from him.
Welcome to today's webinar on preventing contamination and advancing food safety, focusing on the critical need for due diligence in food production. My name is Robert Rogers, Senior Advisor for Food Safety and Regulation with Mettler-Toledo. With 27 years at Mettler-Toledo, I've facilitated customers' development of food safety programs by utilizing product inspection technologies. Today, we're going to focus on and discuss the critical need for due diligence in order to prevent contamination and advance product safety in food manufacturing. We'll start by looking at due diligence and what is due diligence defense as part of my introduction to the topic. Then we'll look at food safety legal requirements and standards relevant to your business before moving on to discuss how you can achieve due diligence through product inspection. At the end, we'll summarize with some key takeaways. Let's take a closer look at the importance of food safety to manufacturers before we delve into the specifics of due diligence and due diligence defense. We'll start with the facts. It's increasingly important for food manufacturers to take every precaution to check that their products are of the highest quality, free from contamination, accurately labeled, at the correct weight, as advertised, and unlikely to harm the end consumer. But why is this so critical? Well, where do I start? By complying food safety principles, regulations, and standards, you can help to avoid product recalls, protect brands, businesses, and consumers. There are different frameworks and guidelines to help manufacturers and work within to help ensure food safety. Among these are the Hazardous Analysis Critical Control Point Principles, or HACCP principles, and the Global Food Safety Initiative, or GFSI, approved standards. There are a number of regulations and standards that manufacturers must comply with in order to trade in certain countries and regions. Many major high street retailers have their own standards in the form of codes of conduct. Other important food safety and quality standards include precision weight standards, such as the Measuring Instrument Directive in the EU. And last but not least, there are a number of labeling regulations to protect consumers against digesting an ingredient which they may be allergic to. And we'll talk about more of these standards in detail. So what is due diligence? Well, there are multiple reasons behind non-deliberate food safety breaches, which can result in a product recall. These can be in the manufacturing environment, the processing method, the production line equipment, and operator errors. In addition, there are well-documented deliberate food safety incidents, such as intentional sabotage, which have also led to a product recall. However, in the event of a product recall, manufacturers must be able to demonstrate that they have the highest level of product quality and they have taken appropriate steps to minimize the risk of litigation, complaints, and recalls. It is critical that manufacturers must have the necessary documentation and evidence to prove that they have been due diligent in the production process should any legal auditing issues arrive. Due diligence can be broken down into two areas: the concept and the functionality. Let's start with the concept. The concept of due diligence is the actual act of carrying out comprehensive quality control checks to verify that the product is safe. This includes that product is free from foreign body contamination, at the correct weight, and accurately labeled. This concept can stretch beyond the identification of critical control points within the manufacturing facility and can be applied to either just the ingredient stage or straight through the complete package on the supermarket shelf. Depending on the product, some manufacturers may want to extend product security to when the product is on the shelf by using certain types of container closures. An example, like with baby food, which can show that the product hasn't been tampered with and can help prove full due diligence has been carried out. However, due diligence can only truly be carried out if an inspection machine has identified the integrity of the container closure. Also critical to due diligence is the functionality of the production line technologies. So what does this mean? Well, simply put, it means the security settings and restrictions to access of production inspection machines, such as X-ray and metal detectors. Having the X-ray system on the line forms a part of the due diligence concept. But for the systems themselves, they need to have some sort of due diligence as well. This could be, as the image shows, the electronically controlled interlocked reject bins, which restrict access only to authorized staff and prevent rejected product from returning to the production line without full investigation. Sophisticated password controls control the security of the system, which means that only product settings can be controlled by those authorized to do so. These measures help to prove that the systems themselves are due diligence, which is vital when discussing the functionality of due diligence. There are a number of food safety standards and requirements. Identifying those that relate to your business will depend on the manufacturing location, the product type, the exportation destination, and who you are supplying the product to, as an example, a high street retailer organization. The Global Food Safety Initiative, known as the GFSI, formed in May of 2000 from a collaboration between international retailers. The foundation to all GFSI standards is defining good practice in hygiene and manufacturing, are the hazardous critical control points and prerequisite programs. Detailed information about HACCP can be found in a white paper that we provide. At the end of this presentation, we'll provide a link for you. Getting back to the GFSI, this global organization now reviews food safety standards and approves those which meet specific criteria. Some of the currently recognized schemes include the British Retail Consortium Global Standards, or BRCGS, the Food Safety Systems Certification, or FSSC 22000, and Safe Quality Foods, or SQF. These three standards form about 90% of all the adopted standards under the GFSI. In China, the People's Republic of China, or the PRC, food safety law, govern food quality and integrity. The law has a number of comprehensive statutory requirements concerning the production, circulation, recall, and import and export of food products in China, including rules of import and export for online trading and food production. Again, the main emphasis is food safety. In India, the Food Safety Standards Authority of India and the state food safety authorities are responsible for ensuring compliance of the FSS Act 2006 rules and regulations. Manufacturers and processors found guilty of producing food products containing extraneous matter at a substandard level and or being the product in an unhygienic premises will be fined set fees. Other important regulations and standards include the Retailer Codes of Conduct, Measuring Instrument Directives, or MID, and nutrition labeling regulations. Let's briefly look at retailer codes of conduct. As previously mentioned, some high street retailers have their own standards and forms of code of conduct, which means that the food manufacturers must have understood the retailer's own standards, comply with their governance. Furthermore, of these retailer codes of conduct is to provide safe, affordable food so people can live better. To achieve this, the retailer set out different criteria based on different product types, from fresh produce to private brands. When considering other food safety standards, we must include precision weight standards such as the Measuring Instrument Directive, or MID, in the European nations. This outlines, and also the European CE Directive, which outlines safety requirements for all measuring instruments sold within the EU. The directive sets standards for both measuring instruments and for softwares. Furthermore, you must also consider nutrition labeling regulations, as previously mentioned. Here we've cited some of the regulations. In the EU, Information for Consumer Regulations, which require food businesses to declare the presence, whether used as an ingredient or a processing aid, of any of the 14 major allergens, including celery, cereals, and milk. In China, food labeling governed is by the administrative measures of food labeling. Prepackaged food must meet the compulsory national standards on prepackaged food labeling. Overall, food labels must contain the name of the food, the manufacturing details of name, address, and contact information, the production date, any expiration date, and list of all ingredients. All products sold in the People's Republic of China must be marked in Chinese language. In regards to labeling laws for compliance and to prove due diligence, vision inspection technologies, instead of people visually checking the labels, will provide manufacturers with an automatic label check at fast production line speeds. This technology is able to inspect 100% of the labels rather than people spot checking. So now we have a firmer understanding of the guidelines and standards food manufacturing is structured around. We must also understand how contamination can occur. The opportunities for contamination to find its way into the product are numerous. One reason is that the majority of the food processing equipment is made of metal, and it's conceivable that some of this could break apart and fall into the product. Other contaminations, such as glass, mineral stone, calcified bone, or high-density plastics and rubber, could also be introduced into the product, either as a result of being included in the raw materials or during the manufacturing process itself. In order to comply with most standards, you're going to have to consider how you're going to control foreign material. All product inspection systems can help to prove due diligence has been carried out. As an example, the X-ray inspection for checking for that foreign material, metal detection, looking for unwanted metal of non-ferrous, ferrous, and stainless steel materials, state-of-the-art checkweighers for compliance for those weight regulations, and those automatic vision inspection systems inspecting 100% of the product, looking at for the label quality and any information checks that may be printed on there. Combining inspection systems offer advanced quality control systems for all product shapes and sizes and can save valuable production line space. Of course, I wouldn't have given my due diligence if we didn't talk about the software to collect all the data that these machines produce. Any of the product inspection systems fitted with a suitable reject mechanism, a lockable reject bin, will go a long way in providing a solution. But for systems to have a system could have a procedural failure and have serious impact on the overall effectiveness of the system. It's vital to reject all non-conforming products. To help achieve this, there are things such as lockable reject bins, air fail sensors to ensure that if a product is rejected, that it gets rejected properly, And then their password protection of those lockable reject bins, preventing unauthorized access to those non-conforming items. Let's recap real quick on the quick important takeaways from this webinar. For me, the takeaways from the webinar are pretty straightforward. Understand the right regulations and standards for your business, but take note they are just the minimum requirements. To comply with food safety standards or labeling regulations, we need to adopt a holistic approach, integrating the right product inspection technologies. Understand and know your critical control points and how to protect them. And please don't think that you only have one. Manufacturers must also ensure their technologies have the right due diligence features in the right positions with the right monitoring systems. And again, record everything. After all, if it's not documented, it did not happen. So finally, we have a number of links which will direct you to a more detailed information. And here you can see those useful links about informations for you to download and get more information regarding the different technologies that we have available. I would like to thank you for your attention, and I believe we have some time for some Q&A.
Thank you very much, Robert. So, okay, here's the first question. How long do I need to keep production records for?
Okay, as with any requirement, you really have to understand whose requirement you're trying to meet, and they may differ in this area. I have seen many different things in regards to how long to keep the information. Oftentimes, it's for 1 or 2 years after the expiration date of the product. So after that product has become expired and is no longer a suitable product, they're usually about 2 years after that we would maintain the records. But again, you would want to find out from the people that you are actually trying to comply with what their specific requirements may be.
Okay, sounds good. All right. Number 2, how can I find out what my critical control points are?
Of course, part of the HACCP program is the first part is the hazard analysis and understanding what potential hazards are present within the production process or within the value chain. And then once you've understood what those potential hazards are, then you're going to implement a means of controlling those hazards. And those means of that controlling the hazard is often identified as the critical control point. The critical control point will really be the last point in the process that you have to control that identified hazard. So there may be other inspection points throughout the process that are not considered a critical control point that may just simply be a quality control point. But those critical control points is really looked as that last line of defense in protecting against those identified potential hazards and risks.
Okay, last question here. How can I persuade my senior management that they need to have systems in place in order to prove due diligence?
Well, for me, one of the easiest ways to look at the cost of a product recall to the business. You have to understand what impact that would have financially, and then kind of measure that against implementing programs and processes to prevent those sort of things. The average cost of a product recall, and these are studies that have been done even 5 or 6 years ago. So these numbers are probably increased over that due to inflation. But back then, the average cost of a product recall was about $10 million. That was including the cost to retrieve the product. That was including the cost to investigate the issues, to alert the consumers of the problem. So there are a lot of potential financial burdens involved in a product recall, and preventing those will go a very, very long way.
Okay, thank you very much, Rob.
Our next topic touches on forever chemicals, the layman term for PFAS, which stands for per and polyfluoroalkyl. PFAS compounds can accumulate in our bodies over time, which can lead to serious consequences like cancer and immune system problems. So Lorna from Agilent will now tell us more about analyzing forever chemicals in food contact materials.
Hi, everyone. I'm Lorna DeLeos, Director of the Global Food Market at Agilent. And today I'm happy to be here and talk about Agilent solutions for the analysis of PFAS in food contact materials. But first, I'd like to briefly introduce who we are at Agilent. We are a company with more than 18,000 employees around the world, focused to advance science and deliver complete and integrated solutions to help you become successful. So we interact with more than 1 million scientists each year, and our innovations span more than 50 technological platforms. So Agilent has been recognized as a sustainable company for many years now, and we continue to lead in our field. So we do innovative R&D. For example, the Intuvo 9000 GC requires less than half the electrical power of a conventional GC. And Agilent has also been recognized for its diversity and was named one of the top female-friendly companies by Forbes in 2022. We also received certification as a great place to work in 20 countries and regions. So now here's our agenda for today. First, I'll give an overview of PFAS, what they are, and the regulations around food contact materials. And then I'll talk about the Agilent PFAS targeted and non-targeted workflow solutions, share some resources, and then give a summary. So let's dive right into it. So per and polyfluoroalkyl substances, or PFAS, are a family of synthetic substances that do not occur naturally in the environment. They have strong carbon-fluorine bonds and are very stable, hence the name forever chemicals. So they can be perfluoroalkyl substances where all the hydrogen atoms attached to carbon in the alkyl chain are substituted with fluorine, such as PFOS or perfluorooctane sulfonic acid, or PFOA or perfluorooctanoic acid. These are two of the most studied PFAS compounds. They can also be polyfluoroalkyl substances where some but not all of the hydrogen atoms attached to carbon in the alkyl chain are substituted with fluorine. Examples are the fluorotellumer sulfonates and the fluorotellumer alcohols. These strong carbon-fluorine bonds makes them chemically inert, thermally stable, and they repel oil and water, and thus they are widely used in non-stick cookware, coatings of paper, and other food contact materials. Studies indicated that the migration of PFAS from food contact materials into food is likely to be the main route of consumer exposure to these substances. What other people did is to reduce the occurrence of PFOS and PFOA, a number of PFAS, such as the perfluoroalcohol and its derivatives, have been used as substitutes to replace PFCA and PFSA in food contact materials. However, studies indicate that these substitutes could also pose health risks to humans, as PFSA and PFCA precursors are more toxic than the perfluorosulfonic acids or the perfluorocarboxylic acids themselves. And these precursors could be absorbed into the human body and degrade into PFOA and PFOS by an oxidation mechanism. So for example, the 8,2-FTOH or the fluorotellumer alcohol and the 10,2-FTOH could be converted into PFOA and PFDA. Now let's look at the regulations globally for food contact materials. So to protect consumers from exposure to PFAS migrated from food contact materials or FCM, Stringent regulatory approaches have been adopted to control their production, their application, and their migration. For example, in Europe, the EU number 10/2011, called the Plastic Food Contact Materials Regulation, limits the use of PFAS in plastic food contact materials and authorized specific migration limits for 14 fluorinated substances to be used in the production and manufacture of plastic FCMs and products under certain restrictions. In Denmark, they issued a special decree which bans paper and paperboard FCM containing PFAS, effective July 2020. It also became the first country worldwide to legislate banning the use of PFAS in FCM. Germany, Denmark, Netherlands, Norway, and Sweden jointly submitted a proposal to ECHA in this year, January 2023, to restrict the manufacture, the use, and the application of PFAS in the EU market. And the POPs regulation, Stockholm Convention, and the REACH list of substances of very high concern, or the SVHC, restrict or eliminate the use of specific PFAS compounds such as PFOS, PFOA, the long-chain PFCAs, etc. Now going to the US, federal regulations allow the use of some fluorinated compounds in FCM. However, more than 26 states in the US have introduced legislation to restrict the use of PFAS, and more than 11 states have already passed or plan to restrict the use of PFAS in food contact materials. So California, New York, Washington, Vermont, Connecticut, Minnesota, and Maine have already passed the related bills or regulations related to PFAS in FCM. In China, the National Food Safety Standard GB 9685 banned PFOS and PFOA in certain materials such as cartons, plastics, and non-stick coatings. And lastly, in Japan, the Chemical Substances Control Law banned PFOA, its salts, and related substances in all consumer products starting in October 2021. So Agilent is a reliable solutions provider offering streamlined workflows for PFAS analysis, starting from sample prep, separation, detection, data analysis, to reporting. Not only do we have reliable and robust instruments, but we have tools to help you succeed. So we have the wax SPE cartridges, PFC-free LC conversion kits, which I'll talk about in the next slide, delay column, LC columns, GC columns, quick connect, stay safe caps, solvent, PFAS-free vials and caps, and data analysis tools and reporting tools. On top of that, we have in-house experts to help you with your method implementation for PFAS. So PFAS is everywhere, which means you could have small levels of PFAS background contamination in the lab. It could come from solvents, filtration apparatus, or the Teflon line tubing in your liquid chromatograph. To make sure you have the lowest amount of PFAS background noise, Agilent has developed the Agilent Infinity PFC-free HPLC conversion kit. It's an easy-to-install kit to substitute key parts on your LC or liquid chromatograph to eliminate all potential contamination without sacrificing the sensitivity. In blue on the top right, we have designed special bottle caps and filters for mobile phases and solvents that are PFAS-free. We also have PFAS-free mobile phases. In red in the middle is the multi-sampler. We have included in the kit the PFAS-free multi-wash tubing kit. And it is important to also use PFAS-free consumables as much as possible to avoid further contamination of PFAS. So we have PFAS-free vials with special caps made of polypropylene, and also the Agilent Bond Elute PFAS Wax SPE cartridges are designed for PFAS sample extraction. On the bottom yellow, you'll see the adoptions we are doing at the binary LC pump when using this PFAS-free conversion kit. An important component of the kit is the Agilent PFC delay column to literally delay potential PFAS impurities from the mobile phases, so the background will have a different retention time than your samples, so that you could distinguish what is in the sample versus what is in the system. And we have the PFAS MRM database, a curated database of around 100 native and isotopically labeled PFAS compounds, so you could quickly build acquisition methods for targeted analysis. So this database integrates seamlessly with our Mass Hunter data acquisition software and is compatible with current models of Agilent triple quad systems. So after LC separation, we need a sensitive triple quad mass spec in order to quantify the PFAS in food contact materials. So here's our triple quad portfolio for LC-MS. From left to right, we have the Ultivo, the 6475, and the new 6495, which we introduced last June 2023 at ASMS. The systems from left to right go up in performance. So for this presentation, I'm showing results from an older version of our triple quad, lower than the Ultivo, but we could still get to ppm levels. We have customers using 6495 routinely for PFAS for future proofing, especially because the limits tend to go down as the years go by. All these three triple quads I mentioned in the last slide have in common is that they are easy to use and they maximize your uptime. Systems are equipped with guided maintenance to monitor the health status, and the system gives warnings if you need to do any maintenance. So for best results, any triple quad needs regular tuning to have the best resolution, mass, sensitivity, etc. in the system. The systems that we have uses AI to optimize the auto-tune so it's faster and better. You can also schedule the auto-tune. For example, you can set it at 5 a.m. every Monday morning so that when you come to the lab at 7 a.m. or 8 a.m., the system is ready for analysis. So on the right side, you can remove and clean the ion transfer capillary in all the three LC triple quad systems without venting the system. So you reduce the maintenance time significantly. The last feature I'd like to talk about is the intelligent reflex. There are many intelligent workflows, but one workflow I really like is the carryover detection, where it adds additional blanks if the system detects carryover contamination. This is to ensure that the carryover is washed out and that the next sample is not affected by the prior one. Shifting now to the GC triple quads, this is our GC triple quad portfolio, the 7000E and the 7010 GC triple quad, with increasing sensitivity from left to right. Building on more than 50 years of GCMS excellence, these two instruments boast new mass spec intelligence to increase instrument uptime and truly lead to more confident analysis. So our GC and GC triple quads offer intelligent self-aware features as well. Self-guided maintenance procedures offer step-by-step instructions on common maintenance tasks. And remote connectivity allows users to access the instrument from outside the lab. And then autonomous features help avoid common GC problems before they affect chromatographic performance and results. Our triple quads also come with innovative self-cleaning of the ion source called Jet Clean, which aims to minimize downtime. So Jet Clean reduces cleaning frequency by up to 90%, as seen here on the right. You only need one cleaning per year with Jet Clean, as opposed to 24 cleanings per year without it. And as I said, Agilent is committed to improve sustainability in our operations and also to our customers. So we have partnered with My Green Lab to have our instruments independently audited for their accountability, consistency, and transparency, or the ACT label. So ACT labels provide information about the environmental impact of manufacturing, use, and disposal of a product and its packaging, so that purchasers can make informed, sustainable choices. We have several instruments that we have the ACT label on, as shown here in this slide. So now let's look at the work done by Dr. Lei Zhu and Dr. Marco Zhang and colleagues in Guangzhou and Beijing, China. As I mentioned earlier, the migration of PFAS and its precursors from food contact materials must also be taken into account to ensure our safety. So the key takeaway of this work is that they were able to develop an integrated method combining LC-MS-MS and GC-MS-MS to simultaneously measure multiple PFAS compounds migrating from food contact materials with great sensitivity, recovery, and precision. So for this work, they use the 6410 LC triple and the 7000C GC triple, as well as Agilent columns. So the migration experiments were done following EU 10/2011 for plastic food contact materials. The samples were exposed first to 4 food stimulants, so acetic acid, alcohol at 10%, and alcohol at 50%, and olive oil, and then incubated at 70 degrees Celsius, collected, and then cooled to room temp. For LC-MS-MS analysis of the aqueous simulants, acetic acid, and alcohols, ethanol was added to the samples and then filtered with a 0.22 micrometer syringe filter, followed by direct LC-MS-MS analysis. For GC-MS-MS analysis of the same aqueous food stimulants, the samples were extracted with dichloromethane, transferred to a headspace bottle, and in it was added the internal standard, which is methyl margaret D33 vortex, and the filtered bottom layer was injected into the GC-MS-MS for analysis. So they added 2 standards, MP-FOA and the methyl margaret D33, to the olive oil food simulant, and then acetonitrile was added. Samples were then vortexed, and the supernatant was filtered and then analyzed by GC and LC-MS. So GC-MS-MS was used to detect 9 volatile PFAS compounds shown here, such as perfluoroalcohols and perfluoroalcohol acrylates, that are not easily ionized in aqueous solutions. So these compounds are more susceptible to ionization in an EI source rather than an ESI source. Therefore, GC-MS-MS was preferred for the analyses of these compounds. In the 7000 CGC triple was used with the EI source and using the MRM mode. They injected 2 microliters at a gas flow of 1.5 ml per minute using a 30 meter DB5 0.25 by 0.25 column. LC-MS-MS was used to analyze 27 straight-chain fatty acids, such as perfluorinated carboxylic acids and perfluorinated sulfonic acids. These fatty acid compounds ionize protons, and the precursor ions are negatively charged in aqueous solution. Thus, LC-MS-MS was used to detect these compounds in the negative ESI mode using the Agilent 6410 LC triple. They injected 5 microliters at a flow rate of 0.2 ml per minute using a pour shell 120 EC C18 LC column and water methanol as mobile phases. So 3 different LC columns were compared in the separation of a mixture of 27 PFAS standards at 100 nanograms per ml concentration. So the Agilent Zorbax SBC18, the Agilent Pour Shell 120 ECC18, and the Agilent Eclipse XBB-C18. While all 3 columns separated the target analytes, especially the N-alkane PFAS, the pour shell was chosen because it completely separated the 27 PFAS analytes using the same gradient elution program. For the selection of the GC column, a low or medium polarity column could get to baseline separations for the 9 target PFAS compounds. Thus, DB5, DB17, or DB35 columns would work for the analysis. On the right are the MRM chromatograms of the 36 PFAS compounds analyzed using LC-MS-MS and GC-MS-MS. So using the same workflow for 70 food contact materials, including paper boards, paper and plastic food packaging, rubber articles, heat-resistant metallic containers, they found that multi-layer cardboard and coated paper board were the main types of packaging in which PFAS compounds were found with an average concentration of 0.02 ppm. They also saw that specific PFAS compounds were found in paper samples at concentrations of 0.01 ppm to 0.05 ppm, and the highest migration of PFAS they saw was 0.08 ppm. The chromatogram profiles on the PFAS in typical samples are shown on the right. The compounds found were mainly straight chain perfluorinated acids and perfluorinated alcohols. Keep in mind that the new models of instrumentation could go lower than these values. In summary, we saw an integrated targeted approach to determine multiple PFAS compounds migrating from food contact materials. And LC-MS-MS is best for fatty acid, PFAS, and GC-MS-MS for volatile fatty alcohol and fatty alcohol acrylates. Integrated workflow has the advantage of simultaneously measuring PFAS with greater sensitivity, accuracy, and reliability. And new GC-MS and LC-MS systems have the smart features to maximize the uptime and simplify ease of use. And Agilent has a complete workflow solution for PFAS analysis with the PFAS-free kits to eliminate background, the PFAS database for factor method development, consumables and columns, and expert in-house application services. So with the few minutes I have, I want to now shift gears and talk about non-targeted analysis of PFAS in food contact materials. Non-targeted analysis of PFAS is useful because in reality, there are thousands of PFAS structures, but we are only analyzing hundreds of them. Standards are scarce and often costly, and non-targeted analysis aid in the putative identification of novel PFAS. For example, Mark Schreiner and James Ford of the US EPA published a paper in 2019 that they found a total of 37 unique PFAS chemical formulas and detected 58 isomers in Cape Fear River in North Carolina using the Agilent 6530 LC QTOF. So we released the next generation LC-Q-Top called the Revident last June 2023 at ASMS. It's a high-res, accurate mass LC-Q-Top with end-to-end intelligence, with several improvements in the fly tube, calibrant delivery system, ion optics, detector, and front end to ensure maximum mass accuracy, resolution, robustness, acquisition speed, uptime, and ease of use. Here are some of the intelligent features of Revident. Tuning and calibration, that's AI-based to find the best parameters and faster. And similar to the LC triple quad, the Revident is self-aware and keeps an eye on the overall system health, its status, and if any maintenance is to be expected. Auto tunes and check tunes can be scheduled before the user comes into the lab, so the system is good to go before they arrive. And last but not the least, there are several, as I said, intelligent reflex workflows, but I'm highlighting two on the right. First is the suspect screening, where the system flags a sus or a suspect in a data independent acquisition or DIA analysis, and the system automatically appends a re-injection of the sample to the running work list to confirm the questionable or identified residues via targeted MSMS. Another workflow that I like is the iterative MSMS, which allows the instrument to continuously acquire data, excluding identified precursors that were identified previously for a thorough characterization of complex samples. FluoroMatch is used for non-targeted analysis. It's an open source solution for PFAS annotation that is freely available from innovative.omics.com. It's a spin-off from Yale University by Jeremy Commell and his team. And I put the download link at the bottom of the slide. It is a vendor-agnostic software, and it provides a fully automated PFAS annotation, taking into account several information such as retention time, isotopic pattern, MS fragmentation, and MS1 accurate mass, and comparing all these information against in silico and class-based MS rules, fragment screening, the EPA database of accurate mass, the mass defect to annotate the PFAS structures, and then to assign which homologous series the PFAS belongs to. So Dr. Stefan Bayan of McGill University and his team did a non-targeted analysis of PFAS in food contact materials. They collected 23 packaging, weighed 0.2 gram of each, cut the samples into thin strips, and then placed them in a 15 ml centrifuge tubes. And then next, they added fresh EPA 1633 diluent, vortex, tonicated, and stored for an hour. This extraction process was repeated 4 times, diluted, and then injected 4 times into the 6545 Q-top for iterative MSMS, where a sample is injected multiple times and then precursors that were previously selected for MS fragmentation are excluded on a rolling basis. So PFAS compounds were detected in negative electrospray ionization mode, and data was acquired from mass to charge 100 to 1100 with MS collision energy set at 0, 25, and 40 electron volts. And PFAS data was annotated through the FluoroMatch software. So a primary FluoroMatch output file is in the format of a CSV file shown at the bottom right. And it also generates a PBIX file for FluoroMatch Visualizer, as shown on the screenshot on the left. So Visualizer shows interactive plots. Each dot there represents a PFAS compound, and you can easily see the PFAS groupings based on mass and normalized Kendrick mass defects. And you also have plots for mass to charge versus retention times, and you also have extracted ion chromatograms. So if you select a homologous series, all visuals, including MS spectra, are updated to show all members of a series overlaid. Then patterns and the outliers could easily be observed. So here are the quantitative results of the study. There's more in their list, but here are the highlights. 6 samples, including a deli paper and 5 takeaway containers, had ppb levels of perfluorohexanoic acid, or PFHXA. Samples 16 and 18, identified as biodegradable grease-proof packaging, have the highest total amount of PFAS. Sample 18, a takeaway container, had 6 PFAS compounds, and sample 16, another takeaway container, had 5 PFAS compounds. So in conclusion, Agilent's targeted and non-targeted workflows on PFAS analysis has the advantage of measuring PFAS in food contact materials with great sensitivity, accuracy, and reliability. So our solution spans the whole workflow from sample prep to lab analysis to data analysis and reporting. And our instruments help increase productivity. Not only could our instruments detect reliably, but they also have the smart features to increase uptime and simplify how to get things done. The intelligent reflex, for example, automatically reruns a blank if a sample carryover is detected, and automatically reruns a sample with reduced injection volume if the sample is out of calibration range. And finally, we have experts to help you get started on implementing these workflows. To learn more about PFAS testing in food, beverage, and food packaging and other contact materials, please check out the dedicated page in agilent.com. It has a lot of information on PFAS regulations, methods, and other information. And it has on-demand presentations as well as posters, application notes, and articles. So please check it out. And with that, I'd like to thank everyone who did the work on the targeted and non-targeted analysis of PFAS in food contact materials from our collaborator and customer labs, and the Agilent folks who helped me in this presentation. You are all amazing. And thank you so much for listening, and I'm happy to answer your questions.
Okay, thank you very much, Lorna. We have one question here for you. When do you use targeted analysis and when do you use non-targeted analysis?
Yeah, that's a good question. So it depends on the question you're trying to answer. If you know what target compounds you're looking for, usually for regulatory purposes or for QA/QC in production, then you would want to do a targeted analysis. Non-targeted analysis is used when you want to identify what's there and see if there are contaminants that you haven't seen before. So research, for example. With that said, there are instruments like the Revident QTOF that is traditionally used for non-targeted analysis that can be used for suspect screening. So we actually have a nice data on pesticide analysis at sub-ppb levels. So that's nanogram per gram levels in broccoli on the Revident QTOF that we presented at ASMS last June 2023.
Okay, okay, the next question is, can you do quantitation on a QTOF?
Oh, yes. Yes, you can do quantitation on a QTOF. So you can do screening to confident identification and still have good mass accuracies, low RSDs, and linear curves using the QTOF. I didn't have a chance to talk about this, but you could actually upload your triple quad method to the Revident QTOF for seamless method transfer. And then the Mass Hunter quantitative analysis software has the same view and overall feel with triple and the Revident, which can help lower training costs. You also have, of course, the smart features in the QTOF to maximize the uptime. So yes.
Okay, the last question is on sustainability, a very popular dominant trend in the food industry. So our company is big on sustainability. Could you talk more about the sustainability aspect of the workflows you mentioned?
Okay. Yeah, that's a great question because Agilent is a big proponent of sustainability. So the instrument must meet the detection limits that are set by the regulatory bodies. That is a must. But on top of that, you have the innovative instruments, like as I said, the Agilent Intuvo 9000, which requires less than half the electrical power of a conventional GC that could help labs be sustainable. We have the My Green Lab Act label in our instruments to provide information about the environmental impact on how the instrument is used, manufactured, and disposed of. And then the smart features of the instruments could help maximize uptime and save on labor and electrical costs. Features such as automatic tuning before you arrive in the lab or anticipating maintenance events or adverse events, the capability to rerun automatically when the sample is out of calibration or if the blank is contaminated could also help reduce the environmental footprint of the lab. The Mass Hunter Quant analysis software makes data analysis simpler and saves you time. And finally, using optimized workflows such as reduced amount of solvent, reduced instrument analysis time, and reduced data analysis time could have a big impact in the overall efficiency of your laboratory.
All right, thank you very much, Lorna.
All right, my pleasure. Thank you.
Our last speaker, Saint, is a food safety and product development specialist. She will provide some useful tips about achieving food safety certification, which will boost consumer confidence, leading to improved brand reputation. Saint, the stage is yours.
Thank you very much, Audrey, for the introduction. Hello, everyone. My name is Saint. I am a food safety and product development specialist. I spent 15 years in the food manufacturing corporate world. Since 2019, I became a food safety consultant and involving in various development projects. Now I am helping food manufacturers and food packaging manufacturers to get their food safety certificate so they can provide their products, their safe products to their customers with peace of mind. Today, I will be talking about the rising demand of food safety certificates for the food manufacturers as well as the food packaging manufacturers, and the overview of the food safety certificates, particularly how the GFSI recognized food safety certificates are structured. I will get very briefly into each segment of the certificate. Finally, we will discuss the food safety implementation challenges for food packaging manufacturers and how to overcome them. For me, whenever I talk about packaging material, this picture came to my mind. By the way, I'm using an AI-generated picture to illustrate what I meant. The scenario is like this. A mother was preparing food for her baby. She opened the easy open end of a new can, and she saw a dead lizard inside the can together with the food. Of course, the mother filed a complaint. She also shared the picture in many mothers groups on social media. I was working for the company that produced this contaminated product. That was the most intense and serious complaint I have ever involved in. The investigation was led by various experts, food safety and quality experts, as well as external press experts. there were many systematic reviews and simulations conducted to identify the root cause of the problem. As you might have expected, one of the likely root causes was the empty can. In the process, there was a step where the empty cans were inverted and air patched before it reached to the filling machine. But according to the simulation outcome, if there is any live lizard stick on the surface, the inside of the empty can, the air patch may not be able to remove the live lizard. It may even force the lizard to stick stronger to the surface. Since I had experienced that investigation, I became very vigilant about packaging materials. And I believe one of the driving forces behind rising demand of the food safety certificate is the customer awareness, customers and the consumers' awareness of food safety issues. Nowadays, more and more food manufacturers require their packaging supplier to get a GFSI recognized food safety certificate. On this slide, I have prepared various food safety certificates and significant segments in each certificate. So in the past, we started with the good manufacturing practices, the traditional GMP inspections. And then later on in the food industry, from good manufacturing practices, which is more tuned towards the manufacturing environment, change to the good hygiene practices, which is more relevant to the food industry. So nowadays in the Codex Alimentarius, it is used as the good hygiene practices, GHP, instead of good manufacturing practices. So for a food manufacturing practice or a food packaging manufacturing facility, good hygiene practices are the foundation. After building the foundation, the facility or the food business operator may establish HACCP, which is a preventive approach to identify the hazards and prevent the hazards from entering to the food. The next level will be a food safety management system. For example, ISO 22000 food safety standard. So in that standard, there are 3 segments. One is the PRP, prerequisite program, which is very much comprised of good manufacturing practices and good hygiene practices. And then HACCP, and the last segment of ISO 22000 standard will be food safety management system elements. For a GFSI recognized food safety management system, I am using FSSC 22000 as an example, but other GFSI recognized food safety management system would also cover key segments like these. The structure and the approach may be different, but the principles are almost the same. So in a GFSI recognized food safety system, the foundation is still PRPs, prerequisite programs, then HACCP, and then various elements of a food safety management system. Finally, the additional requirements or the certificate requirement, the standards requirements. Let me get briefly into each segment. Prerequisite programs are the basic conditions and the activities that are necessary within the organization and throughout the food chain to maintain food safety. You may also see the word food throughout the food chain. So the prerequisite programs not only ensure the food manufacturing or food packaging manufacturing environment is complying with the hygiene and other requirements, it also ensure that necessary preventive measures are taken along the food chain. Depending on the type and the size of the business, the number of prerequisite programs may be different, but for easier reference, I have grouped them into 3 The first prerequisite programs are related to infrastructure. For example, the location of the manufacturing premises, the layout of the building, and also the layout inside the building, how the workflow is happening, material flows, and the workplace structure. Next is the utilities such as air, water, and energy. And the fourth one is equipment suitability, which is whether the equipment surfaces are appropriate or suitable for manufacturing the product, cleaning and maintenance of the equipments. The second group of PRPs are related to prevention of cross-contamination. So it involves the preventive measures for reduction or minimizing the cross-contamination. These include cleaning and sanitation, waste disposal, pest control, personal hygiene, and employee facilities, and warehousing. The third group of PRPs are related to prevention of non-conformities. They include management of purchased materials, rework, product recall procedures, product information, food defense, biovigilance, and bioterrorism. After establishing a strong foundation of PRPs, the food business operator will establish a hazard analysis critical control point. HACCP is a systematic preventive approach of the food safety. HACCP is a systematic preventive approach for food safety. HACCP focuses on the identifying and controlling biological, chemical, physical, and later on radiological allergy hazards in the food packaging and manufacturing practices. HACCP is more of a preventive approach which goes through hazard analysis at each step. There are 7 principles when establishing HACCP. The first is conducting hazard analysis at each step of the process, and then defining which step could be a critical control point. Third will be establishing the critical limits at the control points. And then there is a system to be established in order to monitor how the CCP is controlled. The fifth principle is to establish the corrective action to be taken with the monitoring indicates that a particular CCP is not under control. Meaning when you are monitoring the CCP, sometimes the CCP may go, something at the CCP may go wrong and the critical limit may not achieve. Then there must be a correction and corrective action to be taken. The sixth principle is to establish procedures for verification to confirm that the HACCP system is working effectively. That means even though HACCP system is established, it doesn't mean that it will comply with the requirements at every time. So there must be validations and verifications to be performed to ensure that the system is working effectively as it is planned. The seventh principle is documentation, to establish documentation concerning all procedures and the records appropriate to those principles and their applications. So after establishing the HACCP system, the next segment of a GFSI recognized food safety certificate will be establishing the elements of the FSMS. As it is taking a systematic approach to control the food safety hazards within a food business to ensure that food safety is ensured at all times. Some basics of the FSMS include managing incoming materials, specifications and the product release, record keeping requirements, ensuring that all the activities are taken note of and recorded, and traceability. And then the food safety incident management, which is in case anything goes wrong, how is the FBO ensuring that the incident is well managed? And then the control of non-conforming products. That means in the incident that happened, the non-conforming products are segregated and managed properly. Next will be corrective actions if there is any non-conformities happened. And product information such as specifications are also important basics of the FSMS. You will notice that some of the FSMS elements overlap with the prerequisite programs. For FSSC 22000 as an example, requires additional control measures. They include management of services and purchase material, such as supplier management, and it also requires to have the product labeling to be done right, food defense, food fraud mitigation, then environmental monitoring, and in FSSC version 6, there is food safety and quality culture, and quality control, food loss, and waste. These are the additional requirements of an FSSC 22000 food safety certificate. So now that we have understand the structure of the food safety certificates, now I would like to deep dive into the challenges when implementing these food safety requirements, particularly in the packaging manufacturing environment. The first challenge I have experienced is the tough nature of packaging material manufacturing versus the hygiene requirements of the food safety systems. Because the packaging manufacturing environment can be very tough. It can be hot, it can be noisy, and the volume of packaging material is also huge. So when we talk about hygiene requirement of the food safety certificate, it involves building layout, waste disposal, cleaning and sanitation, warehousing, and personal behaviors. Usually these are often neglected in the noisy and heavy environment of packaging manufacturing. So usual understanding is that it is too hot, no pest will stay. It is too hot, nothing can go wrong. But in fact, during the processing, it can be hot, but after the processing, there is possibility of recontamination into the final products. For example, pests and for example, rats and birds. Usually the warehouses are neglected because people believe that all the final products are already palletized, already shrink wrapped, and nothing can go inside the final product. But actually it is not true. Sometimes even the smallest hole in a pallet shrink can lead pest contamination into the final product. So that is the common challenge I have seen in the packaging manufacturing environment. So how do we handle this problem or this challenge? First, I would say identifying the workflow and defining hygiene zones will be the first step to handle this. Definitely, we cannot wear heavy, for example, overcoats inside a very hot environment, but we have to be very careful in the area where high risk presents. For example, in a bottle manufacturing process line, the empty bottle will come up, will be moving along the conveyor. If there is no protection of the empty bottles, contamination from people, for example, the hair and other physical hazards can get into the bottles. So such an area should be identified as the high hygiene zone, and then appropriate personal protective clothing such as hairnet and also the overcoat should be worn. And the next one is cleaning, sanitation, waste disposal, warehousing, and pest control. We might think that the materials are covered, but by nature of the pest, it can even go through the smallest holes. So we have the one way to manage the hygiene implementation challenge is to identify the most critical areas to be protected, and then practice proper prerequisite programs. Another challenge in the food packaging material manufacturing environment is the traceability. There are huge piles of raw materials in the compound, and the common belief is that the raw materials quality will not be deteriorated. So that is a common understanding, common belief. So it is difficult to set up a traceability system. And also it is another factor that enhances the challenge is the continuous processing. When there is a continuous processing, there must be a cutoff to identify a batch. So to address that issue, first of all, the documented procedure should be in place. And for the logistic purposes, a software system should be used. Only then the traceability system can be established properly. Even though it is difficult to segregate the raw materials, it is good to practice first in, first out as much as possible. Maybe it starts at the next step where just before the production steps. So practicing first in, first out is also important. For the third, I would say the most challenging is training the workforce. Because most people came from the hot and noisy environment, the mindset is that usually the packaging materials, people don't see packaging as part of the food. Actually, packaging should be considered as part of the food. Only then people will have the clear understanding of food safety requirements. So the first hindrance, I would say, is the mindset. And then the second is, as I repeatedly said, it's the environment, the hot and noisy environment. When the environment is very hot and very noisy, people tend to avoid donning additional items on their body. And there are other priorities in the packaging environment as well. For example, to get the quality consistent, and also for people's safety, there are a lot of other priorities. So for that, the management commitment should be the key. Without the management commitment, food safety implementation is almost not possible. And the second step would be selecting the right leader for a food safety team, because the leader can direct the team to the right direction. So in selecting the food safety team, the team members should come from almost all the departments in the company. Only then they will have the sharing and understanding of each processes. Training is a very important element for developing the workforce with the right mindset. So starting with the need assessment, and then develop the correct training, and executing the training plan is another key element. And the last but not least is establishing the food safety culture. The food safety culture generally means that it explains how people pay attention to food safety at workplace. And food safety culture can be seen by anyone who visits the factory. Because even at the entrance, whether people are really following the rules, like for example, whether anybody who is like not practicing personal hygiene, that can be seen. So the food safety culture, establishing food safety culture is a key element. And for FSSC 22000 version 6, it is a standard requirement. In conclusion, I would say that food safety management system is a system of systems, meaning when we did not pay attention to pest control or cleaning or other issues like warehousing, this can link to this can affect other elements as well. So to establish an effective food safety management system, each element within the system has to be established properly as well. So how do we successfully implement food safety? So I would say setting a clear goal is the first step. That's where the leadership commitment is important as well. So for example, if the company decides to get a food safety certificate in 12 months' time, set a clear goal, communicate the goal with the team and the whole company, and start implementing each system. So here, the green dots represent each system within the system. So for example, cleaning, personal hygiene, equipment maintenance, etc. So implement one system after another. At the beginning, it may be slow, but later on, the whole team will gain the momentum, and it is easier to establish the later elements. And then finally, the team will achieve the goal. What happened if people did not really do a proper system setup? I would say at the beginning, you wouldn't notice what is going wrong, but after time, you will see the system deteriorated, and one day the problem may appear as a huge complaint. So the most important point for establishing a food safety management system, the first step is setting a clear goal. And next, the common practice for establishing food safety management system is it starts with assessment. Where are you in terms of prerequisite program, in terms of system setup? And then starting from the assessment, you will see the gap to be filled. And then training, coaching will come after. And then after that, the whole team will be able to implement a food safety management system. And after implementation, there is a key step, which is the verification. Technically, it is called internal audit. When the food safety team is able to audit their own work and assess again whether the status is already meeting the requirements. And after that, the factory will be ready for certification audit. So it all starts with setting a clear goal and followed by conducting assessment, training, coaching, and verification. If any food safety team follow these steps carefully, they will achieve their goals within the specified timeline. So I usually share what I experience on social media. So if you want to connect with me, please connect me here. Thank you very much.
Okay, thank you very much, Sing. That was very, very informative. So we have time for a couple of questions. And the first one is about the prerequisite program. So why is PRP challenging for food packaging manufacturers? Isn't that the foundational requirement?
It is the foundational requirement. And it all started with the GMP inspection, which is not new to the food manufacturer or the food packaging manufacturer. But why is it challenging is because not every packaging manufacturer started with huge facility, very big space, you know. Some of the packaging manufacturers started with like a family business, a traditional business, and then they grow. So when they grow, to to keep all the big volume raw materials and the final products, they have to expand their workspace. Like, for example, there is a building in the middle of a compound or of a space. And when they need space, what they usually do will be expand to the left, expand to the right, wherever the space is available. That after time, that cause incorrect workflow. And when the workflow is incorrect, when the material movement is incorrect, when people put in all the large equipment in the small space, like stuff in, and then it is also very difficult to correct at a later time. I would say the gradual expansion of businesses cause the wrong workflow and the squeezy layout, and that sometimes leads to bigger problems.
Okay, next question here. I'm sure everybody will be interested in this. What is the number one ingredient to succeed in food safety implementation?
Sure. Number one, the top ingredient or the secret to the success is the management commitment, the leadership commitment. Without the commitment, it is almost not possible to implement an effective food safety management system. It starts with the top management commitment, and then it should go down to the middle managers buy-in. So only when they understand the need and why do they have to do this, then they will be able to do their part and also make sure that their teams understand the need and their teams follow the requirements. That is the second step. And the third step is don't forget anyone in the factory, including cleaning, the cleaners or the security guard. Everyone's effort is important in the food safety implementation. So starting with the top management, getting the buy-in from the middle manager, and not forgetting everyone, including cleaners and security guard. That is the secret to success.
Okay, thank you very much, Snain. We've now come to the end of the webinar. Thank you for joining us. We hope that you will walk away inspired and better equipped to improve your food production processes. This webinar will continue to run for another 5 minutes. If you have further questions, type them in the chat box. We will get back to you individually via email. Have a good day.